how is it going? Welcome to our infographic video done for our project 1A of our energy and architecture module, taught by our wonderful lecturers Mr. Bruce and Dr. City. For this project, we were required to do a low energy building analysis of a chosen low energy building, identifying specific energy efficient strategies with their implementation in the chosen building. For this assignment, we chose to focus on United Therapeutics Unisphere.
When United Therapeutics CEO Martine Rothblatt announced a net zero energy mandate across the company, she challenged the project team to make energy performance the primary metric in every design decision. She had two requirements in planning for the Unisphere. One was a regulation pool in the lobby, and the second one was having net zero energy. The result of these mandates and these requirements is the Unisphere, which is the largest commercial net zero building in the world, and it generates more renewable energy than it consumes in a year since its opening in 2018. The United Therapeutics Unisphere is the largest net zero energy commercial building in the United States at 210,000 square feet. Opened in September 2018 as an extension of part of the United Therapeutics existing campus. The building houses offices and conference spaces.
The project is prominently located along a major roadway in Silver Spring, a suburb of Washington, D.C. The site is surrounded by mid-rise buildings constructed to the vertical zoning limit, which create many challenges for the design of a net zero energy project that exclusively utilizes solar panels to generate renewable energy. United Therapeutics believes that the reduction of the carbon footprint of the community benefits us all. As such, the project team embodies this value by pushing the cutting edge of building technology. The culmination of this technology will be a net zero site. This means that the site will have no carbon footprint of operation because the amount of electrical and thermal energy used in operation will be renewable, generated on site. This smart building takes advantage of multiple sustainability strategies, which include the following. It has no operational carbon footprint because the electrical and thermal energy it uses is renewable, generated on the site. 3,000 solar or photovoltaic panels on the building generating 1,175 watts of energy each year, enough to power 100 homes. Beneath Unisphere, 52 to 20 mile long close-up loop, dual circuit geo-exchange wells are drilled 500 feet into the earth to provide energy storage. The atrium pool is used as a heat sink to help balance the overall system and provide passive heating of the pool water. Daylight harvesting allows dimming of the artificial lighting system when adequate sunlight is available. The office area windows uses electrochromic glass technology that changes tint level based on season, location of the sun, and cloud coverage. Operable windows and panels allow the building to naturally ventilate, providing a completely passive ventilation mode between certain temperatures. Excess power is sent back in the utility grid during peak production times, and the utility grid supplies this power back at night and at off-peak times.
There are some additional sustainable design strategies and features which are employed by Unisphere, and this include the different operating modes such as the heating, natural ventilation, ventilation assisted, mechanical cooling, and the night fridge. There is also a stormwater catch basin that's designed to collect nearly 15,000 square feet or 780 gallons per minute of rainwater that prevents overwhelming the city sewer by slowly releasing it at a controlled rate. There is also several vegetated roofs that reduce the heat island effects and help to manage the stormwater runoff. And there is also 200 active chill beams that provide efficient cooling to the spaces. A highly efficient water-to-water heat pump also provides chilled water and simultaneously creates heating water from the waste heat. And there's also heating and cooling systems that utilize environmentally responsible refrigerants with an average refrigerant atmospheric impact of less than 100. With all of these additional sustainable features, there are two other features which we would like to highlight and spotlight from the building. One is the plug load management, and the second one is the centralized building automation system. The planned grid management is often the most difficult energy use point to control in a building, since they are not traditionally designed into the project, but instead are controlled by the user post-occupancy. However, the Unisphere has employed some strategies and policies which help to lower the planned grid management and help keep the building as sustainable as possible. They require the purchase of Energy Star rated equipment or OLED televisions, which help reduce energy use. Also, the IT department has enacted policies that help to force computers into hibernation mode during unoccupied periods, and they also install timers on controllable circuits that de-energize power, as well as all computer workstations being docked with laptops and a separate monitor, which reduce energy by a half compared to traditional CPUs. As for the central building automation system, this is a key ally in reducing the building energy use by optimizing the system performance, setting occupied or unoccupied modes, and setting back temperatures in areas where possible. The interface includes lighting controls, power monitoring, and other building systems into the central control system to further improve performance. And the incorporation of energy meters onto the building's various systems will provide valuable feedback for benchmarking and trending. And all of this valuable feedback can be seen and viewed from the central hub, which monitors the building's energy use and generation in real time. This central hub is called the Energy Dial and the Energy Dashboard, and they use real-time data to showcase the ebb and flow of the building's energy. The sculpture, called the Energy Dial, shines light outward whenever the building is producing a solar energy surplus, and shines light inward if it's using more energy than is being produced. Its form, scale, and behavior encourages a symbiotic relationship between the occupant and building as people understand its story immediately. The Energy Dashboard, on the other hand, helps to view all of the different systems working in the building, and people can use it to view all the real-time data, such as the energy being produced, the amount of energy being used, the amount of energy that's a deficit, what mode the building is in, as well as the amount of energy that's stored and the thermal controls of the whole building. Having seen all of these wonderful building and sustainable technologies being used in the Unisphere, one has to ask if indeed all of these technologies are adaptable and can be used in the developing world. Despite having numerous advantages, clean building technologies are still very slow to be picked up in the developing world. However, as climate change becomes more prevalent and its effects more widespread, both developers and occupants of buildings are becoming more aware of green building technologies and are pushing for new buildings to be more sustainable. For example, in Kenya, sustainable building practices were never thought of much until the success of the Garden City mixed-use development project. This project, which consists of a retail mall, residential apartments, leisure and office spaces, it was announced in 2007 and completed in 2014. In 2015, it was announced that the Garden City Mall had received the LEED Gold certification, implementing solutions which were aimed at achieving high performance in site development, material selection, energy efficiency, water savings, and indoor environmental quality, making it the first building in East and Central Africa to acquire this certification. And key to this was the implementation of a green by design approach, which incorporated environmental measures under the 7 LEED sustainability principles. Key to this was the implementation of the roof of the shopping mall being turned into Africa's largest solar photovoltaic carport, which generated 1,200 megawatt hours of electricity a year. The mall also incorporates water recycling and harvesting systems that significantly reduce potable water demand, which is of vital importance around Nairobi, where the regional environmental priority is water security. Some 50% of the building materials comprise recycled content, with 70% of the construction materials sourced domestically, providing a lot of significant benefits to the Kenyan economy. And now we have come to the end of this video showing our low energy building analysis for the Unisphere. And we hope that this video has been able to teach you something and that you've also been able to learn and enjoy the video. Thank you for watching, have a good day, and I'll see you next time.